Hello, today is October 15th and it is Thursday. And today we're going to talk about setting up our investigation. So let's go ahead and go to This Week in Science. And I wanted to start by telling you that I only have about 7 to 10 kids in each class who actually finished their assignment yesterday, which is types of variables. Make sure that you do that. It is a multiple selection, multiple choice formative that goes over independent and dependent variables as well as constants. All right. Then we're going to go to Thursday, and I want you to open both of these assignments today because we're going to put them next to each other so that you can see what we're doing. And what I would like you to do is go ahead and use the two-finger click. And we're going to open this into a new tab. And then we're going to go to the next one, and we're going to again do the two-finger tap. We're going to open it to another screen as well. So when you're done, you should have 3 screens open. You should have this screen, your digital notebook, and your helicopter investigation. If you have more than that, I would recommend closing out all the other tabs because it might get confusing, and this will help you be able to stay on task for today. All right, then let's go ahead and click on the inquiry notebook so that it makes a big copy of it for you. And then go back to the helicopter investigation, and I want you to click on helicopter investigation so that it makes you a big copy of that one as well. All right. So we're going to go ahead and start with our digital notebook, and we're going to go down to page 10, so slide 10. And now that we've talked about what are the types of variables, we're now going to use that information to help us kind of set up our investigation. What is it that we're going to do for our experiment? And I'm going to go ahead and start in with our notes. So with every investigation that we do, I will be giving you a background paragraph. So the first thing that you want to do is read the background paragraph. And I usually try to link a video of me reading it so that if you want to listen to it while you're reading it, that's fine. Okay. What this background paragraph does is it tells you a little bit of background information. It explains what it is that we're going to be investigating, what are we going to do the experiment on. It's going to give you the independent variable and the dependent variable. And it's also going to explain the science behind what we're looking at. So anything that we already know about how something works that could help us make a good guess as to what the outcome of our experiment is going to be will help us with this investigation. So we're going to go ahead and put that there. And then we're going to form a research question. Okay, and our research question basically sounds like this. How does the independent variable, oops, and that one was green, affect the dependent variable? So an example of this would be, how does the amount of water affect how tall a plant grows? Or how does the number of paper clips affect how long it takes for a paper helicopter to fall? Now we're going to go over to the helicopter investigation, and we're going to go to slide 2, and we're going to practice filling in, doing those first 2 steps. So I'm going to start by reading the paragraph, or the background paragraph. What makes a paper helicopter twist gently to the ground? As it falls, air pushes up against the blades of the helicopter, bending them up just a little. When air pushes upward on the slanted blades, some of that push becomes a sideways or horizontal force. In other words, it kind of pushes those helicopters around. Since there are 2 slanted blades, each getting the same amount of push, but in opposite directions, the 2 opposing forces work together to spin the helicopter. The faster the paper helicopter spins, the slower it falls. A slowly falling paper helicopter will hit the ground with less force, in other words, it'll be gentler. A slow, smooth landing is critical when flying a real helicopter in order to protect both the aircraft and its passengers. If a helicopter lands too quickly, then it will hit the ground with more force, which will increase the risk of injuries to the passenger. In this investigation, you will use a paper helicopter to simulate the landing of a real helicopter. You will see how changing the thickness of the helicopter affects how long it takes the helicopter to fall to the ground, with a goal of slowing the helicopter landing. So I'm going to make my research question. You'll see I've already set it up. So how does changing the IV affect the DV, the independent variable and the dependent variable? So the thing that we're changing is the thickness of the helicopter paper. So we're going to say, how does changing and then I'm going to just copy and paste the thickness of the helicopter paper affect how long it takes the helicopter to fall to the ground. So again, I'm going to copy and I'm going to paste it right here. You'll notice that I've got everything color coded so that anytime that we're going to use the independent variable, it's going to be in blue, and anytime, sorry, in green. And anytime that we do the dependent variable, it's going to be in blue. All right, now I'm going to go back to my notes over here. All right, next step is to identify those variables. What is it that we are going to be learning about? And we have our independent variable, also known as the IV. And because it goes quicker, I'm going to go ahead and highlight, make sure it's correct. I'm going to highlight dependent variable in there, and I'm going to paste it here because we have the dependent variable. And I'm going to change this one to DV. And I'm going to go ahead and paste again, and I'm going to get rid of dependent because we have the constant variables. Constant variables. And those are our CVs. And you will notice that we have this slick little trick here. This is why we filled in that wheel before. The independent variable is on the outside. The dependent variable is on the inside. And the constant variables are all the other things around the outside. So I'll explain that in just a moment again so you can see that. So in the middle, you can see we have the dependent variable. So that would be like the time it takes for the helicopter to fall or how tall the plant grows. Then around the outside are all of the things that could change the outcome of this thing. So if we change any one of the things that are on the outside, it could affect how tall it grows. It could also, or if you're talking about the helicopter, it could affect how slow it falls. And then the IV, we're going to put a box around it because that is going to be the one thing that we're going to change. And it's going to be right there. And then all the others, anything that doesn't have a box around it is going to be our CVs. Those are the things that we're going to keep the same, the constant variables. So let's go ahead and go back over to our helicopter. And let's go ahead and identify the variables. So I see right here that I have my circle or my wheel for this particular experiment. And I'm going to go ahead and use that to fill in these boxes. All right, so my independent variable is in green. This is paper thickness. And my dependent variable, it says how long it takes the helicopter to fall to the ground. That's a lot of words for falling time. And I'm going to do that in seconds. And then we have a lot of constant variables, and you can put as many of these as you want. I usually do at least 3. So I'm going to say, let's see here, height of drop. I'm going to say body size. Type of paper clip. Whether there are holes in the wings or not, so number of holes in the wing. And I could keep going on, but you're going to type as many of those as you can fit. You need to at least have 3. All right, so what this tells us is that this is what we're going to change on purpose. This is what we're going to measure. And this right here, these are all the things that we're going to keep the same. We're not going to change these things. We want to always drop it from the same height. We want to have the same size body for both of our 2 experiments. The only difference is that we're going to change what it's made of. So thin paper and thick paper, right? So we're going to make those changes. All right. Going back to our notes. All right, so now we're going to write our hypothesis. And a hypothesis is just a predicted answer to the research question. And it sounds like this. If we increase the IV, then the DV will, and then we make our prediction. Do we think it's going to increase it or decrease it or make it stay the same? So here's my example. If we increase the thickness of the helicopter, then the fall time will, and then I'm going to decide whether I think it's going to take longer for it to fall as it gets thicker, if it's going to take a shorter amount of time as it gets thicker, or whether I think it's going to have no effect at all. In other words, it's going to stay the same. If I'm doing this one, then I'm going to say that the thinner one is going to take less time than the thicker one. If I choose this one, then I'm going to say that the thinner one is going to take more time than the thinner one, sorry, the thicker one. And if I choose this one, then I'm going to say that it's going to have no effect. So when I drop both the thin and the thick helicopter, they're going to take the same amount of time to drop. So I'm going to choose one of those, and then I'm going to draw a graph of that hypothesis. All right, so let's go ahead and go back to the helicopter investigation. So we can just copy and paste this. If we increase the paper thickness, so if it gets bigger, if we make it thicker, then the fall time will, and then you're going to tell me whether you think it's going to increase or if you think it's going to decrease, or whether you think it's going to have no effect at all. In other words, the time is going to stay the same. And then you're going to do your prediction graph. And I actually set it up already so that we can just drag and drop. So if you thought it was going to increase, in other words, the thin paper was going to take less time to drop than the thick paper, then you're going to grab this one right here and drag and drop it into the prediction graph. If you thought it was going to decrease, in other words, the thin one was going to take less time to drop than the thick one, then you drag and drop that one down. If you thought it was going to stay the same, in other words, when you drop them both, the thin one is going to take the same amount of time as the thick one, then you're going to bring it over to the prediction, that one over to the prediction graph. All right, guess what? You are all finished with today's assignment. At this point in time, I would like you to go back and press the submit button for both the inquiry notebook and the investigation final project. This one is the most important of the 2 so that I can see what you've done so far on that first page. And remember, if you haven't done your assignment from yesterday, that is your homework. If you did your assignment from yesterday, guess what? You have no homework tonight. Good luck.